Okay, so we are going to look into this cache poisoning, which is a very large problem. Okay, so I will try to scale it down firstly to explain what actually cache is and how it actually works. But I will use only one single example for the cache poisoning because there are just a lot of different type of cache poisoning. So first of all, the word cache itself actually refers to memory, all right, or a limited amount of hard disk space. Okay, but it serves the same purpose, one single purpose, which is to speed up certain processes. Okay, so it can cache do exist in your CPU, all right, in your PC, laptop, and so forth. It also exists in servers, for instance, your network servers or even your web servers, okay, or your DNS servers, okay, domain name servers, for instance. All right, so it is used in a lot of places. And when you say about cache poisoning, basically the cache itself become your target. All right, okay, so the hackers or the cyber criminal, okay, depending on the terms that you want to use, all right, actually target this cache to corrupt it, okay, and try to make use of this corruption to their advantage. All right, so it actually can exist, the poisoning can exist in any type of cache, but we will use a particular example that are more related to web communication, all right, since the course itself is more about web application security. All right, so let's say now we are on a very standard, all right, we are on a very standard DNS, all right, domain name server, okay, and what does it do? Well, from your networking subjects, you will know that, okay, whenever I type a URL, it will go to the DNS, and then the DNS will actually tell me what is the IP address, so that my browser can go all the way to that IP address and do whatever I'm supposed to do. All right, so I can access that particular website, for instance. So let's understand what normally happens first. And I call this the normal use case of the DNS with this cache and so forth. So what I have here is just your normal user, okay? So a normal user uses the PC, all right, launch your browser, whatever, and type in a URL. So www something something something.com, for instance. Then this URL is transmitted to, let's assume, a secondary DNS server. So this guy up here is a secondary DNS server, and this guy down here is your primary DNS server. Okay, so they all have memory. The server does has memory, and this particular server over here, which is the secondary DNS server, also have memory, and of course have a section for cache. All right, now if the whatever that was sent over exists in the cache, or exists in this particular machine cache, then this machine, this server over here will just send back the information immediately. All right, so that is the shortcut. Okay, so productivity is heightened, achieved. Okay, so that is the shortest approach. However, for this particular use case, in this particular request that goes to this server over here, right, could not find it in his cache, which means it is not a hit. A hit means I can find it in my cache. It is not a hit, it is a miss. Miss means I can't find it in my cache. Alright, so I can't find this in my cache. So if I can't find it in my cache, I will need help. Okay, so I will ask my primary server, okay, do you have this information? Okay, do you have this information? So I will query the primary server. Okay, the primary server will say, yes, okay, I have everything. So I will give this information, back to this server on the top, okay, and I will need to do two things. Now I'm over here, I will need to do two things. One is because previously I do not have the information inside my cache. Alright, therefore I have a miss. So now I will update my cache. So I will update my cache, okay, so put a copy of it inside my cache. Then I will send that information back to the user, and the user can, do whatever he or she is supposed to do. Okay. That just now is the use case. Alright. No attack at all. Okay, no attack at all. But now I'm gonna explain the abuse case, which basically is the cache poisoning itself. Alright. So the innocent user is still here. Alright. But now we have this hacker. Okay, me. Alright. I want to launch a cache poisoning attack. So I will turn on my whatever laptop, my pen test machines, and okay, so I have all these tools turned on, and I will query this server first. Alright, but this query, I will purposely query something that does not exist. Okay, why? Because if I query something that exists, there is a possibility that it exists in the cache, and then the cache will just have a hit, and then it will send me back whatever the data or whatever direction, okay, that I have. But I don't want that. Right? I do not want that. So I will give a query that for something that does not exist, hoping that it will not exist inside the cache. It will be a miss. Okay. So now there is going to be a miss. So what happens when there is a miss? Well, the server will do what we see just now. Okay, I don't have it inside my cache, therefore it's a miss. Therefore, I will go and ask from my primary server, which has everything. Okay, so the primary server, okay, will do job by responding, right? By doing a proper response, okay, proper information or instruction to this server on the top. But while this is occurring, this hacker will send a lot of information, trying to pretend that they are legitimate response from this server, primary server, which means I am pretending now to be the primary server, and I will craft all this packet that looks like they are instruction from the primary server and to this secondary server over here. Now, what happened? Well, a few things can happen. Firstly, this server up here, if this server up here take this response from the primary server, nothing happened. All right, so the attack failed. All right, so the poisoning of the cache failed because it's obtaining the right instruction. However, if this server take any of the hacker's instruction as the real, as the real legitimate, or he thinks it's a legitimate information or instruction, then the cache become poison because it will update the cache. Okay, because just now there's a miss. So whenever there's a miss, I will query. After that, I will update and send the response back. But now the cache has been poisoned because the cache has updated something that is not supposed to be there. Hence, the cache is now poisoned. Okay, so hopefully so far so good. Okay, but so what? So what if the cache is poisoned? Well, let's continue. So now the cache is poisoned. The user, this is a right user, this is a nice innocent user, do the same thing again. So he requests for a particular information, alright, from the secondary server. But this time, because the cache is poisoned, alright, this information request actually produce a hit. Okay, so if you produce a hit, I will not ask anything from the primary server anymore. Why? Because there's a hit, so I can find it inside my cache. Not knowing that my cache has been poisoned, I will now return this instruction, or I will return this instruction back to the user. But please take note, I'm using a red arrow because this is not a proper instruction. This is not supposed to be the instruction given to the end user. Alright, because of the poisoning. Alright, now I have given a bad instruction to the end user. And what can happen? Well, maybe this instruction actually asks the end user computer to connect to me. Alright, or to connect to any server that I set up anywhere in the world to collect information, to be a man-in-the-middle attack, alright, or well, whatever is my actual target. Okay, but of course, this particular example is more geared toward DNS or cache poisoning. Okay, which will be different from the poisoning of a cache in, let's say, a web browser, right, or application inside your desktop. Okay, but here you can actually see what can happen in the event of a cache poisoning. Alright, so I hope this clarified, okay, a little bit better about cache poisoning.